Yeah, so could one of you please confirm whether you are able to hear me or not?
Yes, sir, you're audible.
Okay, thank you. So let me start whatever we were discussing yesterday. And so what I told you is that IoT fits very well with cloud computing, right? So basically, in the present day, IoT has become very pervasive, and so has cloud become as well. IoT has a huge requirement of having a technology like cloud, which can efficiently store and process data. And cloud computing is something that gels very well with IoT because it is a technology which is not only present almost throughout the world through different service providers, but also throughout the world because there are so many IoT implementations available commercially as well as in the society. So there is already a requirement which cloud technology can fulfill. So as you can see that there is a natural affinity between these two. So I'm going to, after this, I'm going to show you some videos which will illustrate commercially what solutions are available for this integration of IoT with cloud computing. So I'm going to talk about that. And before that, I'm going to cover a little bit more on the standard that we were talking yesterday, this IEEE 802.15.4 standard. So this IEEE 802.15.4 standard is the one which basically has become kind of de facto for implementation of IoT. There are many other standards which are also useful for IoT implementation, but 802.15.1 basically has become a natural choice. The reason is that it gives you specification for particularly the lower layers of wireless personal area networks. Lower layers means what? The physical layer and the MAC layer, right? So for forming wireless personal area network, which is typically the necessity in many of the IoT implementations, this 802.15.4 gives you a standard which can help in running technologies at low cost and catering to the requirements of low power, right? So low power at low cost, low power at supporting different data rates, typically low data rate, because this is what is applicable in most of the IoT sensors. So that is the reason 802.15.4 has been very popular. So 802.15.4, IEEE 802.15.4, as I was telling you yesterday, it can be contrasted with other available technologies such as the same IEEE another standard 802.11, right? So for supporting Wi-Fi, right? So that's also another standard, but basically 802.15.4 gives you the opportunity for low power, low data rate, low cost solution, whereas Wi-Fi is bandwidth hungry. It consumes much more power, right? So although you will find implementations running on Wi-Fi, IoT implementations running on Wi-Fi, but basically, it is, it's not a very good choice. Rather, if you have to go for some wider area, longer range communication, there are technologies nowadays which are called LoRa, LoRaWAN, etc., which are useful for taking your pieces of signal from one point to a long distance, right? So so basically the emphasis is on low cost communication, low cost technology, and to support communication between nearby devices which are part of a wireless local area network, and where there is no existing infrastructure, not like cellular where you need to have existing infrastructure to be in place, or even like Wi-Fi where you need to deploy your access points, right? So where there is no existing fixed infrastructure, where there is no underlying infrastructure, and you need to build up a network uh, which is of low cost and is not only low cost, but kind of infrastructure less means like you do not need to have an underlying infrastructure, existing infrastructure, in order to enable the communication. So in those cases, actually, this technology, this standard is useful for building up protocols and supporting devices. So there are so many different there are so many different technologies, so many different protocols which are basically supported on this IEEE 802.15.4 standard. So in the slide, basically, as you can see, that these are some of these different protocols supporting IoT and cloud computing together. So 6LoWPAN is one, Zigbee is another, then I don't know, I mean, this should not be written over here, 802.15.4, but then wireless HART, so wireless HART, there is something called Z-Wave. For industrial communication, there is this standard called ISA 100 series, then NFC, RFID, Bluetooth, so all of these basically they can be run on top of 802.15.4 specification, supporting the physical and the MAC layers. Okay, so let us look into 802.15.4 in a little bit more detail. As I was telling you earlier, that it is a technical standard for supporting low rate means low data rate wireless personal area networks. And basically, these devices basically consume very low energy. So these are not energy hungry. So these are very because the data rate is also low. The underlying mechanisms also support very low consumption of power. And so basically the two layers which are specified as part of the standard are the physical layer and the MAC layer, right? There are few others also which are there, but primarily this physical and the MAC layer. There are other layers like as part of the data link layer, there is this logical link control LLC, and then there is another one which is called the SSCS, which is the service specific convergence sub layer. So all of which basically are part of the specification of 802.15.4, but primarily it is this physical and the MAC layers which are of the integral interest in 802.15.4. So one thing that I would like to also emphasize over here is that this particular standard operates in the ISM radio band, right? So ISM band, I think most of you already know. This band is basically freely available, and it can be used for communicating these devices which are supported by 802.15.4. And not only 802.15.4, ISM band is used by many different standards, right? So the goal of 802.15.4 is to render a base format to which the upper layers, that means layers 3 to 7, could add other protocols and features. So basically, you are giving the specification for this physical and MAC primarily, and then the other layers which are running on top. Considering a OSI model, for instance, layers 3 to 7. So those layers are going to run on top of these two specified layers as part of this standard. So in terms of some physical layer specification, which I'm not going to go through in detail because it is not required, just it is sufficient for you to know that it runs using the modulation scheme which is called the DSSS, right? Direct sequence spread spectrum. There is another one which is called the frequency hopping spread spectrum, but 802.15.4 uses this DSSS modulation. So there is also high tolerance to noise and interference, the way it has been developed, and this basically, this is something that is desirable for IoT implementations. The reason being that in IoT, the physical environment is typically inherently noisy, right? And there are, there are a lot of, sources of interference as well. So there is high tolerance to noise and interference, and also this particular standard, it offers link reliability improvement mechanisms. So basically, because this is noisy channel, so communication occurs over noisy and interference prone channels. There are actually offerings for increasing the reliability of the links, right? So the low speed versions of 802.15.4, it uses something called the binary phase shift keying. So those of you who have taken a basic course in computer networks or communication, you already know about these terms. This is an assumption that I am making, but just in case any of you are not already familiar with these terms, what I would urge you is that after the class you please note down these terms, and after the class you please just quickly go through them to understand, just grossly understand. You don't have to understand in depth, because that is not what is intended in a course in cloud computing. So you just try to understand like what is the scope of each of these different protocols or these terminologies, right? So in terms of keying, basically binary phase shift keying is used, whereas this is basically for the low speed versions, and for the high speed versions, basically quadrature phase shift keying, QPSK as it is called, QPSK, and there is a variant which is called the OQPSK. The OQPSK variant is typically used in the high data rate versions. And for channel access, basically it is the CSMA CA, right? So this is this MAC protocol that is used. So CSMA CA, but this CSMA CA is little different over here than the CSMA CA that you get in other wireless networks. So basically, it has its own CSMA CA collision avoidance, carrier sense multiple access collision avoidance MAC protocol for use in 802.15.4. So it has its own CSMA CA variant, right, for use in this particular standard. So multiplexing, basically this particular feature, it enables the multiple devices, because there are so many different devices all working together, so that there is no interference between when there is communication, or to minimize this kind of interference. Multiplexing basically helps these multiple devices to access the same channel without interference at different times. Now so there are some different features of 802.15.4. I'm just going to read through this slide, just the list of the features that I have over here. So the first one is that the short packets are transmitted in this particular standard. It is the size of the packets are very short, and these are transmitted infrequently. It's not like very quickly these packets are going to be. So at certain intervals of time, which is not very frequent, using a very low duty cycle rate, less than 1%, which is in turn going to going to help minimize the power consumption. So this is basically one of the important features of 802.15.4, which is used. Low, short packets, infrequent transmission, low duty cycle, minimization of power consumption. These are some of these different features. So the power level that is defined, it is basically -3 dBm decibel meter, right? So which is basically 0.5 milliwatt. So under the best conditions, the transmission range can reach up to 1000 meters. So 802.15.4 is typically used for short range communication, but it can also be used in certain conditions for communication up to about a kilometer. So typical standard transmission range, particularly in the indoor environment. In the indoor environment, the kind of experiments that we have done, we have seen in our lab that in the indoor environment, typically, you are going to get using 802.15.4, a typical value is like 25 to 30 meters or so, right? But if you are outdoor, probably it can even go up to 75 meters or so. So short transmission range, standard transmission range of up to 75 meters is basically supported by 802.15.4. The nature of the transmission path is mostly line of sight. So line of sight communication is mostly utilized over here. Non-line of sight is not quite efficient using this particular standard. And the two topologies that are supported by it are the basic star topology and the peer-to-peer topology, right? So peer-to-peer communication and star-based formation between these different devices. These are actually, both of these are supported by the standard 802.15.4. So I just wanted to show you this particular diagram, which gives you this idea, right? So this idea between so idea of how the different layers which are which are part of the specification of 802.15.4. So typically, these blue colored layers are the ones which are supported and supporting the network layer on top by 802.15.4, physical and MAC, and also SSCS and LLC. These are the layers which are basically underlying the network layer. So these are basically specified as part of 802.15.4, and all of these layers, so this diagram actually is little misleading. This particular dashed line should end over here in LLC, not in the network layer. So so anyway, so this correction is required. But what I wanted to emphasize is that these four layers could be mapped to the OSI physical layer and data link layer, like this. So these, on the left hand side, what you see are the seven layers of the OSI model, and on the right hand side, what you see are the layers which are proposed as part of the 802.15.4, and these are the four layers which could be mapped to only the bottommost two layers, the physical layer and the data link layer of 802.15.4. Okay, so there are different variants of IEEE 802.15.4. So in the same way as you also know, like in 802.11, right? 802.11, there are this A, B, C, G, etc. So you must have noticed, like in your Wi-Fi, if you are purchasing a Wi-Fi access point, right? So it will also give you the standard that it supports, right? So you must have noticed that it writes IEEE 802.11, let us say A, B, and C, let us say, right? So like that, actually the specification, the on the back side of these devices, you will be able to find the particular variant that it supports. So in 802.15.4, these are the different available variants. A and B are basically the base versions of 802.15.4. So base versions means these are the ones that are actually used in this by the device manufacturers. And there is another version called the C version for China. So 802.15.4 C is used in China. 802.15.4 D is used in Japan. 802.15.4 E is for industrial applications. This is something that is interesting and is very much required, particularly if you guys are going to go and work on some IoT projects in the industry. This is typically the one that you will be encountering, 802.15.4 E, right? And then there is the other one, 802.15.4 F, which is particularly relevant for the active RFID users. And then for smart grids, there is this 802.15.4 G, right? So this is basically for the smart grid. So okay, so so let me what should I do? So let me do one thing. So let us, I will not proceed further. So I just wanted to highlight upon some of the different features that are supported by 802.15.4. So there are actually some for the real-time guarantees, basically, so applications which require real-time guarantees. For that, there is a slot which is called the GTS, guaranteed time slot, right? So which is basically supported by 802.15.4. 802.15.4 also has support for two MAC protocols. One is the CSMA, as I told you, but then there is another one which is also supported, which is called the TDMA, right? So both of these could be used in 802.15.4, although CSMA is the one which is most often used, and that is the reason why I have shown only that one in the slide, right? So the TDMA, basically the TDMA mode of operation, it is supported by the GTS feature of the standard, and GTS means the guaranteed time slot, which I told you is essential for real time, the applications requiring real time guarantees and the reservations, right? So 802.15.4 also supports security features. It can integrate the security features for secure communication, then power management functions such as for example, controlling the speed of data transmission, the quality of data transmission, and the energy consumption. All of these things could be basically controlled through the devices, or through devices which are supported by 802.15.4 standard, right? So like this, actually there are many others which are also there, which I'm not going to go through. So what is very important is to understand that in 802.15.4 protocol stack, the two main layers which are supported, the two main ones, right? These are not the only ones, because there are the other sublayer other sublayers which I also mentioned earlier. But the two main standards, two main layers which are supported are basically the physical layer and the MAC layer. So the specification that comes as part of this particular standard basically talks primarily about the physical layer, how the physical layer is going to work, what are the necessities, what are the rules, what are the conditions, and similarly for the medium access control, that means the MAC layer as well, right? So I'm not going to go through any further today. I leave the rest for the next class. What is the time now? Okay, let me do one thing. Couple of more slides. Let me complete, and after that we'll come to the videos, which are very interesting. And I am actually myself, I'm very interested to show you those videos, because that will give you good idea about how and where these things are used in practice in the cloud computing business. So let me just another couple of slides and then we will be done. So IEEE 802.15.4 basically supports two types of devices. One is called the fully functional device, and the other one is called the reduced functional device, FFD and RFD. So basically the idea is that the fully functional device can communicate with all types of devices, and it basically has support for the full protocol stack, whereas the reduced functional devices can only communicate with one of the fully functional devices. So if there is a RFD has to communicate with an FFD. On the other hand, FFDs don't have this kind of stipulation. They can communicate with all different types of devices and are going to support the full protocol stack. So reduced function device basically reduces the power consumption, and for that basically it is required to minimize the CPU runs or the RAM that may be required to support. So on the right hand side is the pictorial depiction of RFD and FFD, and which of these devices are part of which of these classifications. So RFD is basically RFD can be a device, whereas the FFDs could be a PAN coordinator or a router or any of the devices. So these are some of so in the different types of frames that are used as part of 802.15.4, these are some of the ones that I have mentioned over here. So typically these are the ones that are used. So one is the data frame, acknowledgement frame, command frame, MAC frame, and beacon frame. So these are some of these different types of frames. So beacon enabled networks, beacon messages are transmitted periodically, and data frames are transmitted through slotted CSMA/CA with a superframe structure, which the PAN coordinator basically manages. And these beacons are used to synchronize and associate the nodes with the coordinator, right? So these are the two types. Then one is the beacon enabled, and the other one is the non-beacon enabled networks. So the non-beacon enabled networks, the data frames here are transmitted through the unslotted, through using basically the unslotted CSMA/CA, right? So and CSMA/CA, as you know, is primarily contention based, right? So at least the core one. So basically, what happens is that the there is an unslotted CSMA/CA variant which is typically used for data transmission and communication for non-beacon enabled networks. So here basically in non-beacon enabled networks, the beacons are used for only linked layer discovery, and both the source and destination IDs are required, and all the protocol addressing over here in non-beacon enabled networks must stick to the mesh configurations, as IEEE 802.15.4 is primarily a mesh protocol. So as it is a primarily a mesh protocol, so basically most of these are going to stick to the mesh configurations. So communication amongst the nodes are decentralized over here using these non-beacon enabled devices. So with this I'm going to end over here, and as I promised, some interesting videos are waiting for you. Next class onwards, not tomorrow but next class onwards, we are going to start the 6-LoWPAN, and we are going to look into in further detail how this 6-LoWPAN technology works. And so next class I will ask you what is this 6 standing for in the 6-LoWPAN, right? So this is a question, a quiz that I'm going to ask you next class. I'm telling you in advance so that you can come prepared. Let me see, how many of you have done this exercise. Okay, so that's all for today. So any question? I hope that you guys are not sleepy. So and now that I have also permitted you to turn off your cameras, I'm not even sure whether some of the students have actually, they have taken a break and gone elsewhere when the class is on, right? So I hope that you guys are not doing so, and because otherwise actually nothing is going to happen, but you are going to make fool of yourself, and which is going to hurt you in your exams, right? So anyway, let's hope that you don't do such a thing and you are attending and listening to me in the class. Okay, so that's all. Now can I so if you do not have any other questions, do you have any question you can ask?
Sir, will there be a exam tomorrow? Or?
Yeah, there is not exam. Why do you call it exam? Quiz, huh? Quiz means like a lightweight version, right? So fun. It's not a serious thing, right? I mean, of course, everything is serious because there is a weightage that is going to be carried, but these are like low weight, individually low weight ones, right? And the nature of questions, as you have noticed in the past also, are very simple in quiz, right? Which is not the case in the case of these tests will be little bit more. I mean, so even the test questions are also very easy, right? Only little bit more difficult anyway. So that's all. And yeah, so I think let us now request
Sir, hello,
yeah,
sir.
yeah.
Sir, I have a question. Like the apps, like Share It and Zender,